Hello, and welcome to the 2022 Design Expo at Michigan Technological University. My name is Atlas Rosenberg, and I am the current Chief Operations Officer of the HSTEM enterprise. I will be starting our presentation by introducing you to the HSTEM enterprise and giving you a bit of background information on the team. The HSTEM enterprise has three main purposes. First and foremost, the HSTEM enterprise was created to be a home for students from all areas of study. Part of the original vision of the enterprise was to give an option for students from majors that don't traditionally have the option to join enterprise teams. Some of these majors include biomedical engineering, biology, as well as other humanities majors. The second purpose of the enterprise establishes the areas our projects will focus on. In particular, we will focus our efforts on rural health applications where the health science and technology industry doesn't give as much attention. Finally, the third purpose of the HSTEM enterprise is to promote health science and awareness both on campus and in the greater Upper Peninsula community. The HSTEM enterprise is one of the newest enterprise teams at Michigan Tech. We are still in the first year of our team existing, so we have been doing lots of organizational work on top of getting projects underway. We held our first meeting at the beginning of September of 2021 in a classroom in the Student Development Complex, or SDC, and after that, the team has only grown. The constitution of the enterprise was adopted at the end of the founding semester, solidifying the basic operations of the organization. At that time, we had already grown the team to 18 student members. By the team's second semester, we had already secured our own workspace that we could call home, located in the Minerals and Materials building. Currently, the team has further expanded to 20 student members with expectation to have even more next fall. Some of the projects the enterprise has already completed include assisting with the accessibility of the Up and Moving Physical Activity Program and working with the on-campus COVID-19 testing to automate the patient information collection. The HSTEM enterprise currently has two ongoing projects, the bodyweight supported treadmill and the knee recovery device. I will now pass you along to members of these subteams to take a deeper dive into these projects.
The Supported Treadmill Project team is working to design a framed harness system to partially support the weight of physical therapy patients as they perform recovery exercises for lower body injuries. While such systems already exist, our goal is to create a cost-effective alternative that will be affordable for small rural clinics and home users. The system is designed to fit over already existing treadmills that many clinics and individuals already own. In order to meet our goals, we need to take comfort, safety, repair support, and economical components into consideration. The project has been split into three main components. 1. Designing a harness system. 2. Designing a mechanical system to support the harness. And 3. Designing an electrical control system to configure the percentage of weight reduction based on user specifications. Under the harness system, comfort has been a major concern and priority. To address this, our team has prototyped many designs using a variety of materials and put the designs into practice at Michigan Tech's climbing wall. Under all of the systems, we want to focus on user safety by rating our system for weights beyond that of the intended patients. Under the electrical control system, we are working to choose components that can be reasonably sourced and replaced in repair situations. The electronic driver of the control system is being designed to utilize the most cost-effective components as well. In the design process, we are constantly building prototypes and initially building a scaled model of the mechanical frame for cost-effectiveness. We have also divided our team into sub-teams to capitalize on expertise. Our team is formed of majors in biology, medical lab science, mechanical, electrical, robotics, and biomedical engineering. The biomedical engineering, MLS, and biology majors have been focused on the physiology of healing and the anatomy of the human body in the development of the harness. The mechanical and robotics engineering majors have focused on the mechanical system, and the electrical engineering majors have focused on the electronic control system. To keep a central focus, our team has created a set of metrics by which we will define success. Our end goal is to create a system for a net price of less than $5,000, allow for non-weight bearing or recovering patients to be able to use the harness self-sufficiently and comfortably, and allow for both local rural clinics and patients at home to use the system with their own treadmills.
The knee recovery team is creating a way to quantitatively compare the strength of the quadriceps muscles between legs or over time following a leg injury. The user needs to be able to change the weight applied, the weights need to be self-lowering, the machine needs to measure the force exerted by the quadriceps, and it needs to fit users of various sizes and be low cost. The aspect of the design that has been most difficult for us so far is getting the weights to be self-lowering. Some possible solutions that we came up with are a ratcheting gear or a bike wheel hub in the rotating piece that will self-lower the weight while not adding resistance on the way up, or a gas strut which will catch the weight from underneath and lower it slowly. Going forward, we plan on making miniature prototypes of each possible solution out of PVC and then test them and decide which one we would like to move forward with.